During this next segment, we're going to talk about the types of encryption you may encounter in cryptography. Now, when we're talking about types of encryption, really there are two types that you need to know about. There's symmetric encryption and there's asymmetric encryption. Let's talk about symmetric first. Now, you may hear symmetric encryption referred to as secret key cryptography, or you may hear things about session keys or session encryption. That's really symmetric encryption, and just different names for it. Now, the thing about symmetric encryption is it uses one key that's shared between two entities. That's why it's called symmetric, because it's only one side, if you will. Now, this one key, if you would, think of it like a password to an encrypted file. And if someone encrypts a file and sends it to you, they know the password. In order to decrypt it, you have to have the same password, and that's the same key. So the same key encrypts and decrypts the data. Now, secret key cryptography is used to pass encrypted data in transit, like being transmitted and received over the network from one party to another, or to encrypt data in storage. In other words, data that resides on a file system, for example. So you could use it for either way. Now, symmetric encryption is really good for exchanging large amounts of data. In other words, bulk data. It can handle large files actually very well. But one problem that symmetric encryption has is key exchange. Obviously, since we're using the same key, I would have to get the key to another individual if they wanted to decrypt a file I had sent them. So how would I get them this key? Would I email them the password of the key? Not really, because that wouldn't be very secure. So I might send it to them registered mail, or have a trusted authority deliver it, or mail them a disk, or something like that. In any case, it might be problematic to get them the key in a secure manner. Now, here's a quick example of how symmetric key encryption works. You have the data, and you have the key A that encrypts and sends it across to one side, to the other entity, and you also have the same key that can decrypt. So it uses the same key, as I mentioned, for encryption and decryption. Now let's talk about asymmetric encryption. And even though it's asymmetric, that doesn't mean it's the opposite. It means that while symmetric uses one key, asymmetric uses two. So it's not symmetrical. They're not the same key. Asymmetric encryption is also called public or private key cryptography sometimes. So you'll hear that reference to it. Now, asymmetric uses two keys, one that's considered public and one that's considered private. It really doesn't matter which key is which, as long as the one that's designated as private never leaves your possession. The public key can be sent to anyone in the world you like. In fact, a lot of public keys can also be downloaded from central storage, central internet sites. The keys are mathematically related, but you can't use one to figure out what the other one is. You can't derive one from the other. Now, one thing about asymmetric keys is what one key encrypts, the other decrypts. You can't use the same key for both encryption and decryption. In other words, if I encrypt with the public key, the only key that can decrypt that is the private key, and vice versa. If I encrypt with the private key, the only key that can decrypt is the public key. Now, one thing about asymmetric encryption, it does not do well with large amounts of data. It's really good for very small pieces of data. And later on, we'll see why that's actually an advantage when we talk about combining both of these asymmetric and symmetric methods. Now, one thing about asymmetric also is that key exchange is not an issue. It doesn't have to be, because you're using the public key of someone to encrypt data that only they can decrypt using the private key. So you don't have to worry about getting them a secret key. The key they're going to use is public. Everybody has it. Now, in order to communicate between two parties using asymmetric encryption, first of all, both parties have to be issued a pair of keys. In other words, both parties have to have a public key and a private key pair. Each public key is given to whomever, the world, the other party, whatever. So you keep your private key to yourself and everybody else gets your public key. And the reason that is to encrypt something, you encrypt the public key. But if you want to decrypt, only the person you are sending it to can decrypt it with their private key. So it doesn't matter if everybody has the public key. Now, if one party wants to encrypt data to send to the other party, then the first party encrypts with the other person's public key. That other person would then decrypt it with their own private key. Okay, but that's only a one-way encryption. How would you send it back the other way? Well, you would send the encrypted reply using the other person's public key, and of course, that person would decrypt it with their own private key. So it actually works as long as each person has a key pair and each person has access to the other person's public key. Now here's a cute little diagram I've drawn that kind of shows you a little bit about how this works. On one side we have Bobby's keys, the public and private, and on the other side we have Tim's keys, public and private. Now if I wanted to send something to Tim, I would encrypt with Tim's public key and send it to him, because only Tim could decrypt it with the private key, and Tim would do the same thing. So what the public key encrypts, only the private key can decrypt. So I have public and private keys that I can use for this process, and each person has to have one. So that's basically asymmetric encryption in a nutshell, and symmetric encryption as well. Now we haven't talked about the different algorithms that are used for both, and we'll cover that in a later session. But suffice it for now to know how symmetric and asymmetric keys work.